Hello class, this is a continuation on the sum and product of roots. In this video we'll be applying it to cubics. In the same way that sum and products of quadratics can be found, this same method can be applied to even cubics. So a cubic has at most 3 roots. If we expand the first two, this is just like the quadratic. If we expand this further, that becomes x times x cubed. This becomes this one, x times beta gamma x. Moving on to this expression, alpha, negative alpha times x squared. Negative alpha times this expression here, it's positive alpha beta plus gamma x. And negative alpha times positive beta gamma, negative alpha beta gamma. These two have x squares, so we can factor both of them here, leaving us with alpha plus beta plus gamma. These terms here, if we expand this, we got alpha beta, alpha gamma, and from there we can factor out x. So it becomes alpha beta plus alpha gamma plus beta gamma. And the last one is negative alpha beta gamma. This is just multiplication. And just like this being congruent to the general form of a cubic, oh, I just realized this needs to be cubed, and this needs to be cubed as well. My apologies. These coefficients match each of the terms. So we make this monic dividing by alpha, and this gives us a being 1, alpha plus beta plus gamma equivalent to this, alpha beta plus alpha gamma plus beta gamma is equivalent to this, and negative alpha beta gamma is equal to D on A. In summary, just like what we did with the quadratic, we get these 3 rules. So now that we have these, let's actually apply them to a few questions here. Let's copy this and let's paste it as an image so we can drag it around. All right. So from here, first what we need to do is make sure we clearly state what A, B, C, and D are. So A is 1, B is -5, C is 1, and D is -1. So now, alpha plus beta plus gamma is what we will need to answer this. Well, alpha plus beta plus gamma is negative B on A. Is equal to negative B on A, so negative -5, that's 5 over A, which is 2. Since we're going to square both sides, this will give us 25 on 4. So that is the sum of roots all squared. For an expression like this, what we need to do first is expand our terms. This will give us alpha beta plus alpha plus beta plus 1. So we've expanded these two, leaving us with gamma plus 1. Just rearranging these to make my multiplication a little bit easier. Expanding this, multiplying, that becomes alpha beta gamma. Gamma plus alpha is going to be alpha gamma. Alpha plus beta is going to be, just keeping it in alphabetic order, beta gamma. And then gamma times 1 is plus gamma. Moving right along, we're finished with this multiplication. 1 times alpha beta is alpha beta plus alpha plus beta. 1 times 1 is just plus 1. Now, we're going to rearrange everything so that we have some of these identities showing here. Take a look very carefully. We have alpha plus beta plus gamma. Grouping those three together, we already have this expression here. Grouping these three together, we have another expression there. So alpha, beta, gamma. And hopefully I didn't miss any. We have alpha beta, alpha gamma, plus beta gamma. We have the third one there. Alpha, beta, alpha, gamma, beta, gamma, plus 1. Now that we have all three of these, all three of them are now being used. So all we need to do is just substitute the values that we need. Well, as we've seen, the sum of these is already 5 on 2. So we have 5 on 2. This one's new, so we need to find the value here. Alpha, beta, gamma is negative d on a. So negative 1 divided by 2. That's going to be positive half. Alpha, beta, alpha, gamma, beta, gamma is c on a. c on a is 1 on 2. And lastly from here, we're finished with this expression, plus 1. All in all, adding all of these together, I can see this is going to become, that's going to be 2 on 2 plus 2 on 2, 5 on 2. That's going to be 9 on 2. So all of this is equal to 9 on 2. We have one more example. You can pause it and give it a go yourself, or you can watch me answer it right about now. For this, we need a common denominator. For the common denominator, it's going to be the multiplication of all three. So alpha, beta, gamma. Gamma. So we already have an expression for that one there. Now think about this. For alpha to become this denominator, we've multiplied by beta and gamma. So 1 times what's missing, we get beta gamma. Likewise, for beta to become this denominator, we need alpha and gamma to multiply to give us that. So alpha, gamma. And you can probably guess that this last one needs alpha times beta. And now take a look. We have this expression, which is the sum of these roots and the product of all the roots. I'm going to write this using a division symbol. So this is equal to c on a, and as we've seen, it's going to be 1 over 2. So half over, so I've just changed this as a division. So this divided by this. So 1/2 divided by alpha, beta, gamma is negative 1, because negative d, so negative 1 on a. That's going to be positive half. Half divided by half is just going to be 1. So that's one application of the sum and product of roots. I hope to see you in the next video. Best of luck.